In this section, we're going to look at the distance formula. And the distance formula states that for any point x1, y1, and another point x2, y2, the distance between those 2 points will be d is equal to the square root of x2 minus x1 squared plus the y2 minus y1 squared. Let's say, for instance, on this graph, to the right, let's say this point here was x1, y1, and this other point up here was x2, y2. So if I want to find the distance between these 2 points, the distance of this line segment, we can look at the following. If we draw a vertical line amongst that point and a horizontal line amongst that point, we'll see we'll have a right triangle. And as we saw in an earlier section, with our Pythagorean theorem, the a squared plus the b squared is equal to our c squared. Now our c is the hypotenuse, that's the distance that we want to find within here. So if I look at this side, what's the distance from this point down to this point? Well, that's just going to be the distance between the two y values. And if I look at the distance between this point and this other point, that's the difference of the x values. So as you know, for this right triangle with the Pythagorean theorem, the a squared, which we can call x2 minus x1, and the b squared, which is y2 minus y1, we can add those two together, and that will be equal to our d squared. So we just take the square root of it, that is what our d will become over here. So again, according to our Pythagorean theorem, this whole formula comes into play. So if you forget, if there's a plus or minus in between, you can just remember to yourself that the a squared plus the b squared will be equal to this c squared, or that's the distance. Okay? So let's take a look at our problem. Let's say I want to find the distance between the points 3, negative 4, and negative 1, negative 2. Now I'll just let the first one be the points x1, y1, and the second one to be the points x2, y2. So the distance between those 2 points, as our formula shows, is just the x2 minus the x1 squared plus the y2 minus the y1 squared. Now it doesn't matter which one you call x1, y1, x2, y2, just as long as you keep these subscripts together, our first point and our second point. Okay, so if I plug all these values in, we get the square root of negative 1 minus 3 squared plus the negative 2 minus the negative 4 squared. Let's see, negative 2 minus 3 is negative 4, and you square it, that becomes 16. And negative 2 plus 4 is 2, and 2 squared is 4. So the distance between these 2 points is the square root of 16 plus 4. That's the square root of 20. Or in simplified terms, we'll say the distance is 2 times the square root of 5. And that's our distance formula.